Hello friends, welcome to my channel again. In the last video, we understood the definition of programming language and machine code. If you find any doubt or any problem, just comment below and I will reply you back for sure. Before continuing with lesson 2 for today, I recommend you to make your own notes. According to me, making notes is the best way to learn anything. So when you write something, it helps you to remember that thing for a long time. So make your own notes while watching these videos, okay? So in today's lesson, we are going to learn these topics: the assembly language, high-level language, compiler and compiled languages, interpreter and interpreter languages. We are going to cover these topics in today's lesson. Machine code versus assembly language. Now we are going to compare the machine code and assembly language so that we can understand the actual meaning of the assembly language. Okay, so let's start. Machine code is a series of numbers 0 and 1 which is difficult to understand for everybody, okay, right? So if a machine code has an error, then it is very hard to find the mistake in a machine code. Nobody can find a machine code's error. For example, we can take example of a machine code, just try to figure out the error, or you can try to understand the machine code if you can. Okay. Uh, okay, this is the example of a machine code. Can anybody tell what does it mean, or can anybody find what error this code contains? No, because it's quite hard for us to figure out, right? Because it's very difficult. So accordingly, an assembly language came up with a better solution. An assembly language is written in words instead of using numbers. It is the same as machine code, but the only difference is that an assembly language is written in words while machine code is written in series of numbers. Right? Now I think you are able to understand the difference between machine code and assembly language. Machine code is written in number of series, right? 1010, but assembly language is written in words instead of numbers. The only difference between both are machine code in numbers, assembly language in words, right? Okay, now we are going to learn about assembly language in detail so that we can understand its definition quickly. Just let's start. Okay, an assembly language is a programming language in which a mnemonic is assigned to every machine code instruction. So what does it mean? What is mnemonic? In simple wording, mnemonic means any letter, any code, word, any pattern which help us to remember something. Let's take an example. To remember the order of 7 colors in the spectrum of white light, we use a mnemonic WebGear, which we made using the first letter of every color, right? Rather than remembering these 7 color, we just made a word WebGear to remember these 7 color and their order. We don't need to remember these 7 colors in order. So in the same way, in the machine code, we don't need to learn, we don't need to remember those binary code or binary numbers. We just assign a mnemonic to every machine code instruction. So rather than typing those numbers, we just write a word. Did you get my point? So rather than writing those numbers, we just made words in the assembly language so that it would be easy for us to understand that or remember that. So it means that a programmer doesn't need to remember the exact numbers in machine code to tell the computer what to do. The program just needs to give instructions in words to perform a task on a computer instead of writing binary code. Okay, so let's take an example of an assembly code so that we can see what it looks like. And here we go. Okay, so this is an assembly code. You can see here this is printing hello world, and we didn't use the binary instruction 0 and 1 in it, which we used in the previous chapter in the machine code. In the machine code we used 1 and 0 to give the instructions to CPU, but in this code we use the words to give instructions to CPU. So you can see here these are the words which we use in this code, and every word in it is called mnemonic, which is assigned to every binary code instruction. So always remember one thing, that computer only understand machine code 1 and 0, not anything else. Okay, so if we invented assembly language, it doesn't mean computer will understand it. We invented it because it could help us to write the code. It become easier for us to write the code. Computer can't understand assembly language. So assembly language should be converted into machine code before executing on a CPU. Okay, so the assembler was invented to convert assembly language into machine code so that computers could understand it. Did you get my point? Computer can't understand assembly language. We need to convert that code into machine code. For example, this code right there in front of you can see the words in it, right? Global, main, external, printf, or blah blah blah. Computer can't understand this code. We need to convert this code into machine code before executing on a CPU. Okay, and for this work we need an assembler to convert from assembly language to machine code. Okay, just a second, I will show you an example as well. An assembler is a software tool to convert assembly code into machine code. First of all, we write assembly code which is human readable, like we use words in it, right? We can read the assembly code. And after that, assembler convert the assembly code into machine code. Then machine code execute on computer. Machine code executes on computer. It means like we can't run the assembly code on computer on CPU directly. We have to convert that assembly code into machine code before executing on computer. And this is done by assembler. Assembler help us to convert the assembly code into machine code. Assembly language is the same as machine code. It is written in words, but still it is difficult to understand. And the same as machine code, an assembly code can be used only for that CPU for which it is written, not another one. Therefore, a better solution was needed, and that solution was high-level languages. You can see an assembly code in front of you. You can see this is printing hello world, but still it is a big problem for human to understand the assembly code, to learn the mnemonic for each instruction, right? So the best solution was needed, that was high-level languages like C++, Python, PowerShell, Perl, and these languages are executable on every CPU. CPU architecture doesn't matter in it. So high-level languages, which are we are going to learn in the next slide. Just hold on. High-level languages. Now we are going to learn the basics of high-level languages. The assembly language is succeeded by high-level languages like Python, C++, Perl, PowerShell, Java, PHP, JavaScript, and many others. These high-level languages are human-readable and easy to write. Besides this, every high-level language has a strict structure and syntax. It means you have to follow the rules while writing the code. For example, while writing C++ code, you have to write the semicolon at the end of every line. Otherwise, your program will not work. In the same way, every language has its own rules, syntax, and structure. Next, high-level languages can be used for any CPU architecture. We don't need to write different code for different CPUs. Code written for one CPU can be executed on another one. As we know, computer only understand machine code, means instructions written in the form of 1 and 0, right? Computer can't understand the assembly language, so we use assembler to convert assembly code into machine code. In the same way, high-level languages are not read by computer, means computer can't understand the high-level languages. So we use interpreter or compiler to convert high-level languages into machine code. Means assembler convert assembly code into machine code, interpreter or compiler convert high-level languages into machine code. In high-level languages, the source code is converted into machine code by using software tools called interpreter and compiler. Compiler and interpreter convert source code into machine code, but both work in a different way. Let's start with the compiler. Compiler converts the source code into machine code before it can be run on CPU. Okay, means when we compile our source code, compiler will generate a machine code. Compiler will generate a objective code, means when we compile our source code, it will generate a file which we can say objective code, or you can say machine code, whatever you want. Okay, it will generate a objective code, and that code will be run on CPU to get an output. Okay, means source code will be compiled by compiler to generate a machine code, and that machine code will be run on CPU to get an output. Compiler works in this way. Okay. Okay, so if you still didn't understand what compiler is and how it works, don't worry about it. I made a separate video to show how compiler make a new file from source code. Okay, so let's begin the practical channel. Today I'm going to show you how compiler make an objective code when we compile our source code. Okay, so I already installed the GCSync compiler on my laptop, which I will show you in my next video how to install it. So first of all, I suggest you whenever you write your programs, always save your programs in a specific folder so that it become easy for you to find them and run them with the specific directory in command prompt. Okay, so that's why today I'm going to make a new folder so that I can save my all C++ programs in that one. So I'm going to make a new folder in my C drive. Where is my C drive? Here it is. So I'm going to save my new folder on my desktop. Here I'm going to make it. Okay, so okay, you can save your folder with any name, so I'm just going to save it with programming. So you can see here, like, this folder is empty. Okay, so our next step is to write the program. Okay, so I'm just going to open up my notepad. Okay, here we go. You can also use notepad plus plus if you have. Okay, okay, so here I'm taking example of one C++ program to teach the concept of compiler. Okay, so I'm just going to write one simple program which will print only, the hello world. Okay, Okay, this is our simple program, and this program will print hello world. Okay, so now I'm going to save this program in the same folder which I made before. Okay, I'm going to save this program in the same folder with name hello. Okay, so this is the C++ program. Then you have to save this program with cpp extension. Okay, hello.cpp, and you have to select all files. Okay, then save it. Okay, now I saved my C++ program on my desktop in programming folder. Okay, so now I want to see my program. Okay, here's the upper program. So now I'm going to open my command prompt because I want to run this program. Okay, I just write cmd right there. I'm just going to open command prompt. So this is our command prompt where I will run my program. So okay, so I'm using GCC compiler for C++ language. So the command to run this program is g++, then name of the file, which is hello.cpp. It is taking time. Okay, so I just run my program right there. You can see here nothing happened, means we didn't get the output from hello.cpp. What was our program? Our program was hello world program that will print hello world when we run it. But when I run this hello.cpp, it didn't do anything, right? So why nothing happened? You can um, just think about it. Why nothing happened right there? Because I already taught you that compiler converts the source code into machine code before it can be run on CPU. Like C++ is written in words, right? In human readable language. So, but computer only understand machine language, right? So, compiler convert this code into machine code before it can be run on CPU, according to the definition of compiler, right? Source code will be converted into machine code, then machine code will be run on CPU, right? So where is our machine code made when we run our hello.cpp file? You can see here we were having only hello.cpp file, right? But when I run this program, a new file has been generated, right? Before that, you can see that I have only cellular.cpp file, but when I run this command g++ hello.cpp, it generated a new file that is our objective code. Okay, according to the definition, you can see right there, when our source code is compiled by a compiler, which we compiled right there, a new file should be generated, which is this one, A, and this A file will be run on CPU. Okay, now I'm going to run this file. I'm just going to write A. Okay, when I enter it, it will give an output which is hello world. It is giving an output to me hello world. Okay, so this is um, clearing the definition of a compiler. I'm using GCC compiler on my laptop to run C++ program. When I run it, it generate a new file A. okay, which is our objective code, which you can say a machine code. When we run a file on my command prompt, it is giving output to me, right? So now the definition of a compiler is clear. What compiler do? Compiler generate a new file from a source code, right? When we compile our source code, compiler generate a new file on your laptop, on your system, okay? And that would be run on CPU, and we will get an output by running that objective file or objective code, okay? So this is the definition. I think everything is clear to you. If you find any doubt, you can comment below. I will definitely reply you back as soon as possible, okay? Okay, this is okay. So what are compiled languages? That high-level language is called compiled language, in which source code is translated into machine code through compiler before it can be run on CPU. For example, C++, Java, C are compiled languages, right? The languages in which we compile the source code and get an output, right? That languages are called compiled languages, okay? When we compile the source code, it generates the objective code which will run on CPU. The programmer don't need to share the source code with others. He can share the objective code and it will work same for others as you are getting the output. Our source code is saved in this way. Secondly, if we send our objective code to others, nobody can make any change in that because changes can only be made in source code. Okay, so did you get the meaning of this paragraph? Like, for example, in the last video, we see like we were having a hello.cpp file, and when we compile it, we generated a new file called A, right? If your friend want a code from you that prints hello world, right? You don't need to share your hello.cpp file, that is our source code. You don't need to share that file with your friend. You can share only file A with your friend, and this A file will print hello world to your friend as well. Okay, in this way our source code will be safe and we don't need to share that file. The important thing, your friend can't make any change in file A because changes can only be made in source code, not in the objective code. So your friend can't make any change in your file A. Okay. Then next one. A compiler can check the source code upfront. If your program has some errors, then your program will not run until all the errors get fixed. After fixing the errors, you have to recompile your program again. For example, if you forget to write the semicolon at the end of the line, means this is error in your program, and your program will not run when you try to compile it. When you try to write G++ and your hello.cpp, your program will not run, your program will not compile. If you want to compile that program, you have to fix those errors, and after fixing those errors, you have to write the same command again, G++ hello.cpp, means you have to recompile it again. Okay. Interpreter converts the source code into machine code during the runtime. Okay, when you run the program, when you run the source code in the command prompt, our interpreter convert that source code into machine code when we run it. Okay, when we enter the command, okay, our source code will be converted into machine code through interpreter during the runtime. Okay, I'm going to show you through practical how it works. Channel, today I'm going to show you how interpreter works. So let's begin. We already made a folder in the previous video to save over all the programs, so I will save my programs in programming folder. Okay, and I'm taking example of Python language, which is the interpreter language. So I already installed my Python interpreter right there, which we will use to run the programs. Okay, so let's start. Okay, I'm going to open my notepad and just type one simple code which will print hello world. This is simple Python program. I'm just going to save that program in my programming folder on my desktop. So this is the Python program. So you have to save your program with extension .py. Means .py is the extension. You can save your program with any name, sk, but you have to write extension, that is .py, and you have to select all files, then save it. Now this is our Python program. Okay, so let's take a look at the definition. Interpreter converts a source code into machine code during the runtime. Means when we run the program, it will convert the source code into machine code during that time. Means there is no any extra step between source code and programming running. Okay, there is no any extra step. Interpreter just convert the source code into machine code during the runtime. So let's start. Just open your command prompt, cmd. It is. You don't need to put any extra command, just type the file name, that is sk.py, sk.py, then enter. Okay, here it is. It is giving us the output hello world. Means when we run the program directly, we don't need to put any extra step. It will directly give us the output. Means interpreter convert the source code into machine code when we run it. There is no any extra step. Okay, interpreter languages. The interpreter language is a programming language in which source code directly executes on the processor without compiling, and it is translated into machine code by interpreter during the runtime. For example, PHP, JavaScript, Python are interpreter languages. Okay. Interpreter run the program line by line while compilers scan the code all together. Okay. And if you want to share the program with others, you will share the original source code and anybody can change that source code. Means interpreter doesn't make any objective code. Okay, so you have to share your original code if you want to share your code with someone. You don't have any objective code so that you can make your source code safe. You have to share your source code with others. Okay, I hope you understood the compiler and interpreter. Just compare the practical videos of compiler and interpreter and you will get the proper idea of how compiler and interpreter both works, right? So thank you for watching and please do subscribe my channel and have a good one.